Hello, my name is Dr. Joan Kazi, and I'm the geography instructor at Wenatchee Valley College. I'm going to be talking to you about climate change. Geographers are very interested in how humans and the environment interact, and climate change is our most pressing issue in terms of this sort of interaction. So I'm going to share my screen with you now, and we're going to look at some slides that will help us understand how climate change impacts wildfire, because that's one of the biggest consequences for us here in North Central Washington. So I'll start with this photograph of planet Earth. And what's so exciting about this photograph is you can see the source is from NASA. It was actually taken from the Apollo 17 space mission. And it was the first time that humans got to see the Earth from this perspective, to realize that we were all connected. No matter where we live on this Earth, we share the planet as our home. And it gives us everything we need. It is a closed system. It provides us with the water we need, the food we need, and the fresh air that we need to breathe. But having said that, here's another NASA photograph that shows how thin the shell of the atmosphere is. If we look up into the sky, we might think that it goes on forever, but it's actually quite a thin shell of the troposphere, about 10 miles up, where we can breathe and where we live our daily lives. But sadly, we are putting 152 million tons a day of global warming pollution into that thin shell of the atmosphere. This is how it works in terms of the greenhouse effect. Solar radiation comes from the sun, light waves. It gets re-radiated back out as heat energy, but some of it is trapped by the atmosphere, warming the planet, right? And that's important because we do want the greenhouse effect. We don't want to be a frozen planet. The problem is that as carbon dioxide concentrations increase, more of that outgoing heat energy is trapped. And that's what's leading to global warming. So when we're talking about greenhouse effect and the gases in the atmosphere that act as a blanket that trap that exiting heat, not allowing it to leave the atmosphere, what are they? Well, this is a pie chart from the Environmental Protection Agency that shows you what the different greenhouse gases are. The largest is carbon dioxide. About 57% of greenhouse gases is carbon dioxide from fossil fuel use. Now, fossil fuels are oil, which we know mostly as gasoline that we put in our car, but it's used for other purposes as well. Natural gas, it can be liquefied or it can be in the gas form, and coal. And we burn these as energy sources to create electricity, to power our vehicles, and run our factories. Another greenhouse gas, in fact, a very efficient heat-trapping gas, are the F gases, known as chlorofluorocarbons and the other fluorocarbons, but they're a very small percentage of the greenhouse gases in the atmosphere. Nitrous oxide is also about 200 times as heat-trapping as carbon dioxide. So it is a worrisome greenhouse gas. However, once again, there's only about 8% of that in the atmosphere compared to how much carbon dioxide there is. And then there's methane, which is about 20 times as heat-trapping as carbon dioxide. So we're also concerned about methane as a greenhouse gas. The rest, you can see 17% is carbon dioxide that is emitted due to deforestation and the decay of biomass. It can also come from landfills where we throw away our trash. Another part of the greenhouse effect is the role of the forests themselves, right? And so the forests, like all living plant matter, are part of the carbon cycle. And what that means is that they absorb carbon dioxide out of the atmosphere, and then through the process of photosynthesis, they create the foods that they need. They can store that carbon dioxide either as wood in the trees, and other plants can help take it into the ground to store it in the soil. So they have a very important role in balancing the amount of carbon dioxide that we have in the atmosphere. The more trees, the less heat-trapping greenhouse gases will be in the atmosphere. So this is a little animation of the biggest sources of greenhouse gases. And really what it shows us is the human causes of global warming, of the greenhouse effect. And much of that is burning fossil fuels, goes into our transport, whether it's trucks or airplanes, cars, and then of course mining for the fossil fuels like coal mining, also burning them in the coal plants, industrial processes from factories, landfills from our waste, oil production at sea and on land. All of those things are fossil fuels. And when we burn them, when we use them for energy, or when we're mining for them, and they emit their carbon, their methane, and their nitrous oxide, it creates these greenhouse gases. Now, we also have industrial agriculture, which is a source of both nitrous oxide and methane. And we have forest burning, deforestation. This is a graph that shows you the global surface temperatures and how they've departed from the average temperature. And what you might notice here, well, we have a little blip at around the 1940s to 1950s, and then it sort of cools off a little, but it really starts rapidly increasing from the middle of the last century, the 1960s, 1970s, until today. We can see quite a departure in terms of hotter than average. And what I want you to note here is, why do you think we start at 1880? Well, 1880 was the beginning of the instrumental record. That was when we were able to start keeping those temperatures, when we had the measuring devices that we could have around the world in different, we have 4 major temperature reading stations, and we have been collecting that data since 1880. So many of these graphs that you will see start around that time. It was also the time that we began the Industrial Revolution. And with the Industrial Revolution is when we started harnessing the energy of fossil fuels to run our factories and to run our vehicles. So now we're starting to see what the outcome of the use of those energy sources really is. 19 of the 20 hottest years on record have actually occurred since the year 2001. And the hottest of all have been the last 5 years. So what this trend shows you is we are really heating up the planet. I'd like to tell you a little story now. This is my life story in carbon dioxide. And what it's really about is parts per million, or ppm. So many people, many researchers believed that the safest level of carbon dioxide parts per million molecules in the atmosphere was 350. And that as humans, we needed to try to make sure that we weren't putting more carbon dioxide in the atmosphere that would raise us against that 350 parts per million global temperature, parts per million carbon dioxide, because that would raise the global temperature to dangerous levels. Now, what you can see, I was born in 1961, so I'm old, but at that time, the parts per million of carbon dioxide in the atmosphere was only 317. And then as I went through my life, I graduated from high school, it went up to 337. I graduated from college, 344. I got married, and it was still going up, 353 parts per million. Yikes, we went past that 350 parts per million in my lifetime. My second son was born in 1993. It was up to 362 parts per million. I got my doctoral degree and it was 366 parts per million. We adopted our daughter from India, and at that time, in the year 2000, it was 371 parts per million. And then I was trained as a climate reality leader relatively recently, and it was already 406 parts per million. And today, the best estimate is about 415 parts per million of carbon dioxide in our atmosphere. This is what is creating this heating effect. I want to remind you now about the hydrologic cycle, and I hope you all remember this from your science classes. But you know, we never lose water on Earth. We're in a closed system. It just changes form. It evaporates off the oceans and the lands. It becomes water vapor. It rains out, and then it gets into lakes and rivers and underground aquifers and eventually returns to the sea. So why I bring this up is that one of the major effects of the warming of the atmosphere, the warming of the planet, is that we are shifting, moving, sort of unbalancing the hydrologic cycle. And so that's where we're seeing a lot of the effects of this heating. The extra heat that we have in the atmosphere evaporates more water from the oceans, right? Because heat can evaporate water. And that leads to ever larger rain events and floods in various places. Then we're also evaporating water out of the land. And that leads to droughts and drier conditions, especially in places like where we live, which is known as the arid West. It's already a relatively dry climate. So these shifts, this greater heating, is evaporating more water, creating larger floods and more extensive droughts. Here's another impact on our region of climate change. We rely on snowpack, okay? And as the warming of the Earth takes place, we're losing ice more rapidly. It's not building up in the same way that it used to. So on the left, you see the Lillian Glacier in the Olympic National Park, which is part of Washington State. And first you see a photograph from 1905 where you can see the glacier was quite extensive. But by 2010, it had pretty much disappeared. So it really is this idea of now you see it, now you don't. That over the last 100 years, certainly, especially in the last 50 years, and we know especially in the last 20 years, we are losing ice rapidly. And so that water cycle, right, is shifting again. And those ice packs, the snow that we rely on in the North Cascades, in the glaciers for the headwaters of the Columbia River, those are depleting. Those are becoming less. And so when we rely on that every year for our water source, we are seeing that it's not there when we need it, especially at the end of summer, when it's the warmest, and we want that water for irrigation, for our agriculture to grow our food, or to cool our industrial systems, or even just for our own recreation, right? So water is very important. And when we lose it, in the sense of it's not there as snowpack so that it melts slowly over the year, but rather it melts rapidly in the spring, and then we don't have enough when we really need it. It impacts us as humans, but it also impacts our vegetation, and it impacts animals as well. So the problem with this drying and this heating is that in our region, we are seeing more wildfires. So there is a correlation between warmer years and more wildfires, larger fires. Here's a graph of acres burned by wildfires in West Coast states. This is particularly problematic in the US in the West Coast. Now, there are other countries that are also suffering from wildfires, Australia, even up in Siberia, which is so fascinating because you think of that as a really cold place, but the Arctic is warming very quickly. So we're seeing wildfires in places for longer and starting earlier and having even more intensity, larger fires in these regions. I wanted to show you this graph because it includes 2020 in the light blue, and it shows you how many acres were burned in California, especially this year. Oregon was also hit pretty badly. So was Washington. It's our second worst year for wildfires, 2015 being our worst. Now, the problem with this larger, faster, more intense wildfires is that it increases the risk to residents, people living in these areas that are close to forests, that are close to the grasslands that are burning. And it also, of course, puts at risk the emergency services that are trying to put out the fires, are trying to protect us, and trying to provide for people who have to be evacuated and animals and the like. So why are we seeing more of this? It's because of these warmer temperatures with global warming and the drying of our landscapes, drier forest fuels, drier grasslands. We're seeing sometimes windier conditions that can stoke up these fires as well. And so we're in this era of megafires, is what they call them. Also, where they're taking place is important to realize because we have more people living in what we call the wildland urban interface, or the WUI, building houses in places that are more vulnerable to wildfire now. And that puts us more at risk as well. Also, the firefighters who need to, who put themselves in harm's way to protect both those structures, people's houses, their animals, and people themselves. So we've got these dual things going on. And when we have these mega fires, we also know that burning of those forests releases carbon dioxide. So that kind of wildfire can actually create global warming as well. It's not only caused in part by global warming, but it also can then create it. So it is this double whammy. Of course, we want to think about who is very vulnerable to smoke waves that come with wildfire. And you see a couple of maps down there. One is a projection into 2050 that areas in Washington state, in Idaho, Oregon, and California are going to see more smoke and poor air quality because of what's happening with wildfires in our region. That wildfire pollution, that air quality, we look often at PM 2.5, the fine particles of pollution and what it can do to humans, irritating the eyes and the lungs. It can create asthma and breathing problems. Heart disease effects are worsened. Obviously, it's not good for your lungs, and it can lead to higher mortality rates. So there are health concerns that come with the air quality as well. So don't despair. We know what we need to do. And there are many people who are trying to work on this and really trying to find ways to help make our forest landscapes more fire resilient, right? And this is done often through controlled burns. So you see on the left-hand side here, where you make sure that the conditions are just right, the Forest Service is involved, and they are managing to burn off what might be more fuels that could lead to a mega fire. So if they can get rid of some of those more low-lying fuels, then the fire can't reach the forest canopy, which is what makes it so problematic and how it can spread so rapidly. The other thing that is happening is forest thinning, right? So trying to get rid of the thinner diameter trees that could become fuel for the fires, thinning them out so you have the older growth, the larger trees that become a more traditional forest landscape, because fire is actually a natural part of our landscapes here where we live in the western part of the United States. Native people used fire controlled burns to try to make sure that the landscapes didn't explode into megafires as well. So we can use fire as a way to manage our forests, and we can also try to find ways to get rid of some of that forest fuels to make them more resilient. So, you know, who really cares about climate change? Well, why I brought this up is because I'm hoping that everybody cares about climate change. This is a global issue. It's one that we are becoming more and more aware of. The scientists are doing a lot of research. They have a lot of knowledge about what's going on and how we can take care of it, how we can try to draw down the carbon out of the atmosphere, how we can sequester it or capture it in forests, in healthy soils, in healthy landscapes, and also how we can transition from fossil fuels, which are the big culprit really, to cleaner sources of energy, like we have here in the Wenatchee Valley in north central Washington, hydropower, using water as an energy source to run turbines at the dams, right? That creates hydroelectricity, and it's clean. It doesn't put out carbon dioxide. Or use solar power or wind. You might have seen the wind machines. Wind power is another clean source of energy that we need to move towards in our, and making our transportation plugged in, electric vehicles plugged into that hydropower, like our link buses are. So it's really actually your generation. It's kids, it's young adults who care a lot about climate change, because it's your lives that are most impacted. And you didn't do anything to cause this problem. So a lot of times we see that youth are taking the lead. Sometimes they are helping educate other kids. They're bringing it to the attention of political leaders. They're speaking out. They are creating videos and finding ways to help other people understand how important it is that we address this global issue and that we take care of these things. We take care of our one home, the earth, in a way that it will keep it livable for all of us going forward. So I want you just to think now at the end of this little presentation about what you can do to help our forests, to help address climate change, to make sure that we have this healthy planet that we all love. And one thing you can do is talk to your family about it. Talk about what you've learned. Do a little bit more research. Learn more from the quality scientific websites. I'll show them on the next slide. But talk to your family and friends about it. Now you might see there some hands, right, holding soil. Healthy soil is actually another great way to keep carbon out of the atmosphere. So compost, have you heard of compost? Compost is when you use food waste, for example, and you put that food waste, instead of throwing it in the garbage can, you find ways to put it back into the soil. And so sometimes that's done through programs in the cities, in municipal centers, food waste composting programs, but even in households, there can be some composting that's done. And that's a really important solution as well. Bicycling, walking places, trying not to drive as much unless you have an electric car that is plugged into hydropower. Then finding other forms of transportation is something else that you can do. And also just conserving energy, right? Using the LED light bulbs, turning off the lights when you leave the room, conserving conservation of energy and our resources is really the way to go. And then the question is, so now what will you do? This is a call to action for you in your own life and protecting our future, because we're all in this together. So I'm going to leave you now with a couple of resources here, references, and I want to make sure that you know you can try to contact me also. That's my email address. And if and when you go to Wenatchee Valley College, please try and take a geography course. But the Climate Science at Climate Central is a great website to do more research. The Climate Reality Project, I used a number of their slides in this presentation with permission from the Truth in 10 presentation. The EPA, the Environmental Protection Agency, NASA is a great website for climate science. National Geographic, of course, also has a lot of environmental information. NOAA, the National Oceanic and Atmospheric Administration. And then I also used as a source this University of Washington research. So thank you all for listening, and I hope to see you sometime soon.